All right, so back to the Doppler effect. As I was saying, the siren of a police car, ambulance, or fire truck, if you're standing on the sidewalk and let's say the marker is the fire truck, it's getting closer to you, the siren pitch begins to sound higher. And then as it goes away from you, the pitch becomes much lower. That is the Doppler effect. So you may hear something like this, woo 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 wee 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 woo 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 woo. I know it's a terrible example. You guys can laugh at me virtually, but that's the Doppler effect. So scientists over time, especially Edwin Hubble, he's named after the Hubble telescope's named after him. He noticed that galaxies and stars in the universe from Earth were giving off a blue shift or a red shift. So if you were to look at the color given off by objects moving away from you, they give off a red shift color. So the longer wavelengths give off a reddish color. Things moving towards an observer would give off a short wavelength, and that would create a bluish color. So astronomers and scientists like Edwin Hubble have begun to notice that galaxies and stars, when observed from Earth, are giving off a red shift in the visible light spectrum, which indicates that these galaxies and stars are moving away from Earth. So this confirms that the Big Bang happened, causing things to move in an outward direction from wherever they began. If you went to Mars, if you went to the moon, and you looked at the same galaxies or stars, they would also be giving off a red shift in color. So this is a good example of this object right here, which is a light bulb, going away from the observer. The wavelengths are longer, so it gives off an appearance of a red shift. This observer here, the light is coming towards this observer, so the wavelengths are shortening, and it's giving off a blue shift in color. So I've drawn a really cool picture showing this. So here's Earth with an observer up top, and if you notice the galaxy over here to the right of the screen has long red shifting wavelengths. So that galaxy is moving away from the Earth, and the galaxy on the left is shifting in a blue color. So if that galaxy were moving towards us, it would be a shorter wavelength and would be considered a blue shift. So that's the idea of this red shift, is that stars and galaxies are appearing to move away from Earth. Looking at our next slide, cosmic background radiation. So this is describing the energy that's left over from the initial event that created the universe. So there are still tons of thermal and radioactive radiation in the universe, telling scientists that at one point there was this massive event known as the Big Bang. And then thirdly is quasars. These are the oldest known objects in the universe. They are found on the far outer reaches of the universe, and are thought to be the first celestial objects to be created from the Big Bang. So in review, we have the Doppler effect, which is showing us that stars and galaxies are moving away from Earth. We have cosmic background radiation, and then finally quasars. There are other pieces of evidence that are being used by scientists to explain the Big Bang and cement it as the true theory of the formation of the universe, but we only need to focus on Doppler effect, cosmic background radiation, and quasars. So please watch this video. It's really, really funny. It does a great job of explaining what the Doppler effect is. All right, that being said, sorry I was going through so quickly, but I have 5 minutes, a 5-minute limit on this video, so didn't want to stop it again and redo a video. Anyways, hope you guys enjoyed this, and the Big Bang's a really cool theory. I wish we could have done this in class, as we could have done some more balloon activities to describe the formation of the universe, but we will have to settle with a computer lesson. Anyways, hope you guys are good, and thanks for tuning in. Peace.